Now, to finish this tutorial, I will briefly mention how to talk to your collaborators about adopting open science practices and give you some suggestions on how to go on after this class, whether it means learning about open science or teaching it. Collaborators may not be in agreement about open science practices. It might be on you to convince them. Hopefully, this tutorial would already have given you some good reasons why both the whole team and you as an individual researcher would both benefit from your study adopting open science practices. Adopting open science practices can benefit the whole team and project because it ensures that the infrastructures of the project will be usable for future generations, also within your research group. Open access papers and papers which come with open data also tend to have a citation advantage over papers that don't provide their data or papers that are locked behind paywalls. One last reason that it would matter for you as an individual researcher to adopt open science practices is that science is evolving. Open science is becoming increasingly important, and it isn't a very risky bet to assume that it will become increasingly important on the job market. Finally, something I have noticed is that often co-authors aren't hostile to open science practice per se, but they don't want to spend time on it. In this case, if producing transparent, reproducible, and open research matters to you, offering to take on you the extra time and efforts is usually a good way to overcome resistance from collaborators. That being said, open science practices don't necessarily take more time, and you can actually save a lot of time by having a reproducible workflow, especially so if there's any project you would consider revisiting at a later point in time. The idea behind this course was really to provide you with a primer over the range of practices included in open science, and to do so with some degree of generalizability. Another goal of the course was to make you at ease with the different terms used in open science and make you comfortable navigating, exploring, and getting deeper into any of the topics we have touched on. Now, there are a number of resources you can use to learn more about open science, and I'd encourage you to explore and find what works for your scientific practice. To start with, some suggestions are listed alongside this course on the tutorial's web pages and within the supplementary materials section of the tutorial on Complexity Explorer. There are also some other resources I will mention here, even if we have already encountered most or some of them. I can recommend having a look at the Center for Open Sciences website, but also YouTube channel, and also have a look at the Turing Way's website. This list of resources is obviously not exhaustive. If for some reason you cannot find what you're looking for, simply researching the name of the open science practice you are interested in plus the scientific field usually gets you good research results. The same logic applies to practice, for instance, reproducible workflow combined with the methods or programming language you are using, let's say R or Python. Another continuation of this course for you might not only to be learning more for yourself, but also possibly to teach open science. And related to this, open education is one last aspect of open science that we haven't talked about yet. Open education is defined as resources, tools, and practices that are free of legal, financial, and technical barriers, and can be fully used, shared, and adapted in the digital environment. The idea is to remove as much as possible obstacles in the way of accessing knowledge, including financial costs. Open education also often exploits current technological possibilities, meaning internet, to make educational contents available to all, including geographic areas which might not have very well-developed educational institutions. The Complexity Explorer platform is an example of open education, as are a number of other massive open online courses, including edX or Coursera. There are also a number of open textbooks projects, like for instance the Core Econ textbook series in economics. Open education is a huge domain, so I'm specifically going to discuss open education resources for teaching others about open science here. This tutorial, to start with, is an example of open education for open science. We already encountered quite a few platforms, websites, and organizations that you can turn to. So I will just mention here a few more open educational resources that you can use if you want to teach open science. FORT, F-O-R-R-T, for Framework for Open and Reproducible Research Training, offers a lot of valuable resources. There is also a much larger, massive open online course project on open science, which is taking off the ground. And finally, the Center for Open Science includes an open scholarship knowledge base, which compiles freely accessible educational contents on open science. Now that you have had an overview of the different open science practices, I can only encourage you to put in practice what we have talked about. Let me stress that what matters is trying. It's an incremental process. And what matters is to make any step in the right direction. So don't let doubts get in the way. A not perfect but online code is better than a perfect code that isn't shared or available. A study which hasn't been pre-registered but for which code and data are available online is better than one that is not pre-registered but also does not share neither data nor code. Reasons for adopting these practices in a piecemeal fashion rather than wholesales are multifold. They range from selecting what makes sense for your own research to ethical constraints or simply available time and energy. Full disclosure, even if I designed this course, I am still working on making my own scientific practice more open. If you engage in these practices, it's also good to signal it, for instance, as part of when you are presenting your methods. Requiring badges for your open science practices doesn't only reward your effort, but also participates in increasing the visibility of open science practices. And in turn, this matters in creating a larger scale change in scientific practices. One of the last thoughts I'd like to leave you with is that opening science improves science in a number of ways. It makes science more transparent and makes it possible to evaluate and scrutinize scientific outputs. In turn, this matters both for science to be able to self-correct and to increase the general public's trust in science. Open science also participates in increasing diversity in science. But there are other ways to improve science that are relatively independent from opening science, and that's also a direction I invite you to explore as well. They include calls for reform and stressing what are ways to, for instance, build better theory or better links between theory and experiments. If it's a direction you are interested in, there are papers linked in the syllabus you can dive into. As a very final word, I hope this course will become at least slightly outdated for two main reasons. First, because open science practices would become mainstream and part of most scientific curricula, such that it wouldn't really make sense to present open science as separate from a general scientific methods course. In other words, to go back to a paper I mentioned in the first unit, open science will simply be known as science. Second, open science and its associated practices are still fairly young. We are just starting to get an idea of what their actual impact is. This means that we can expect open science to evolve and for its effect on science to become more quantifiable. Some practices might actually turn out to not be as effective as thought of, and some new ways to make science more open might emerge. As we get to know more about the actual effects of each practice, not only the practices might change and improve, but the reasons we adopt them for might also change.